Okay, so we're just going to talk about some basics of drawing number lines. So one thing that's always good to have on our number lines are arrows. So we don't want to imply that there's ever a beginning or an end to our number line. So the arrows show that the number system keeps going in both directions. So then just some basics of our number line. So um, we're always going to have a starting point. That starting point is not always going to be the same. I'm going to start looking, okay, so maybe I'm starting here at 0, and then I'm going to add 30 to that. So when I put that jump in there, I'm going to write that I'm going to add 30 or increase by 30 up there. And then here on my number line, I'm going to record where I'm at that point. So on my number line right now, I'm at 30. Then after that, maybe then I want to add 10 more. So I'll record that I added 10 more. And now the position that I'm at on my number line is 40. From there, maybe I want to add 3. So maybe there's my 3. And now I'm at 43. And we're not solving a particular problem right here, but if that was my conclusion, then maybe I circle my 43 or something like that. I wouldn't say that a student has to, another student, instead of doing their plus 3 like that, they might write the 3 individual jumps, and then I would maybe show that as plus 1, plus 1, plus 1. That's kind of your judgment based on, does the student need to see that as one and one and one, or did they, we want to make sure we record it how they thought about it. Did they think of it as just a plus 3, or did they think of it as 41, 42, 43 to get there? We don't always have to start at 0 though. We could just start recording at 30. So sometimes in addition problems, like if it was um, 37 plus 13, we wouldn't have to start at 0. We could start just at 37. So that's why we have an open number line, because we're giving students a flexibility to start wherever they want. And then maybe some students would see, hey, I'm only 3 away from 40. So they would add their 3 to get to 40, and then they would recognize that it's just 10 more than that. So add our 10, and we're at 50. Similarly, we can show subtraction on a number line. So maybe I'm going to start here at 80 and subtract 40. So I'm going to write my minus 40 up here. That's what I'm doing on my number line. And then I'm going to record down here what my value is. So if I subtracted 40 from 80, I'm at 40. If I subtract another 10, now I'm at 30. Then maybe I want to subtract 2. So I'm at 28. A number line can also combine several operations. So maybe I'm starting at 30, and instead of adding, I don't know, 38, I'm going to instead add 40, so I can show my plus 40. That would get me to 70, and then I'm going to subtract 2, and that got me to 68. So we can show both increases and decreases on the same number line, but we're still recording it the same way. Above the jump, we're showing how much we changed, and then along the line, we can show what value we're at that process in the problem. So one thing you'll notice on those, I wasn't recording anything underneath the jumps. So in here, I didn't have any space. And one reason for that is that when we get into multiplication, we can record important information in there. So one example might be if I was looking at doing 6 times 18 on my number line. So maybe I would first think, well, I could do 6 times 10. So 6 times 10, that's a jump of 60. So I'm going to show that I went up to 60, and I could record in here that how I got there was 6 times 10. So it's a way that we can record and keep track of where we're at. So now I've noticed that I decomposed 18 into 8 and 10. So now I just need to do 6 times 8, So I know I'm adding 48, and so that would get me on my number line to 108. So we want to be consistent in recording the amount that we're jumping up here over top of the jump, and then where we're at along the number line, we're going to write down here below the number line so that that space in the middle is saved for that important information later.